There are often multiple ways to solve quadratic equations, but the goal is to solve it with minimal effort. For example, each quadratic equation can be solved with the quadratic formula, but that might seem like overkill for some of the simpler ones. So my recommended order is first, look to see if it's a special product. This could be something like difference of squares or the perfect square trinomial. The second is to use the AC method. And lastly, I go for the quadratic formula. I already have videos for each of these specific topics on my channel. Now, let's get started. Here we have 6x squared minus 7x equals 5. I always start with writing this so that it equals 0. In this case, we have 6x squared minus 7x minus 5 equals 0. Now, it's in ax squared plus bx plus c equals 0 form. So, my first step is to check to see whether it's a special product. You can see this is not the difference of squares, and it's not a perfect square trinomial. So, let's try the AC method. AC method says that we're looking for two numbers, p and q, where p multiplied by q is equal to AC, which in this case is equal to 6 and negative 5. So that multiplies up to negative 30. And we're also looking for two numbers, the same two numbers, that will sum up to b, aka negative 7. Now, let's list the potential factors. As you can see, p times q is negative 30, so we know that p and q, one of them is positive and one of them is negative. So let's write these down. 2, 15, 3, negative 10, 5, negative 6, 6, negative 5, 10, negative 3, 15, negative 2, 30, negative 1. And then let's see which of these pairs matches the sum of negative 7. This is negative 29, this is negative 13, and this is negative 7. So we know that we found it. We have 3 and negative 10. Now we're going to write this in a different form. We're going to write negative 7x as 3x minus 10x. And then we're going to factor by grouping. So this gives us 6x squared plus 3x minus 10x minus 5 equals 0. So let's group these two and these two together. So 6x and 3x, we can group out a 3x. Gives us 2x plus 1. And here we can group out a negative 5. So let's do that. We got negative 5, we get 2x plus 1. Now we can group out the 2x plus 1. Gives us 3x minus 5 and 2x plus 1 equals 0. So we know our two solutions are going to be when 3x minus 5 equals 0, or when 2x plus 1 equals 0. So we know 3x equals 5, so x equals 5 divided by 3, or 2x equals negative 1, so x is equal to negative 1/2. So our two solutions are x equals 5/3 and x equals negative 1/2. For this one, we have 5x squared equals negative 19x plus 5. Same as last time, I'm going to move everything to one side, so one side will equal 0. This gives us 5x squared plus 19x minus 5 equals 0. Now that it's an ax squared plus bx plus c equals 0 form, we're ready to get started. My first check is that this is not a perfect square trinomial, and it's also not the difference of squares. So we're going to start with the AC method once again. So we're looking for two numbers, P and Q, that multiply up to AC, which in this case is 5 times negative 5, which is negative 25. And we're looking for two numbers that will add up to B, which is 19. So let's write this out. Because P times Q is a negative number, we know that one is positive and one is negative. We can write 1 and negative 25, 5 and negative 5, negative 5 or 5 again, and also 25 and negative 1. So these are all the possibilities. So let's sum them up. This gives us negative 24, 0, and 24. As you can see, none of them sum up to 19, which means we can't solve this using the AC method. So, AC method does not work for this one. That means we have to go to the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So now, let's plug in our values. This gives us negative 19 plus or minus the square root of 19 squared minus 4 times a, which is 5, times c, which is negative 5, over 2 times 5. This gives us negative 19 plus or minus square root of 19 squared, which is 361. There's two negatives here, which make it a positive. 4 times 5 is 20, times 5 is 100. 2 times 5 is 10, which means our answer is negative 19 plus or minus the square root of 461 divided by 10. Our two answers is x equals negative 19 plus the square root of 461 all over 10, and negative 19 minus the square root of 461 divided by 10. Here we have 9x squared minus 16 equals 0. Our first check is to see whether it's a special product. Does this look like the difference of squares or a perfect square trinomial? Actually, yes. It looks like the difference of squares. In this case, it's a difference of 3x squared minus 4 squared. And what's special about this is that a squared minus b squared can be factored as a plus b multiplied by a minus b. This means that this can be factored as 3x plus 4 times 3x minus 4 equals 0. So we know that 3x plus 4 equals 0, and 3x minus 4 can also be 0. So this means that x is equal to negative 4/3, or x is equal to 4/3. Here we have x squared plus 8x minus 33 equals 0. Let's start by writing ax squared plus bx plus c equals 0 on top, so we know what a, b, and c are. Now, does this look like a perfect square trinomial or the difference of squares? No, it doesn't, which means we're going to start with the AC method. So we're looking for p times q, that's equal to AC, which in this case is 1 times negative 33, which equals negative 33. And p plus q is going to add up to b, which in this case is 8. Now, let's look for our numbers. Because p times q is negative, we know that one of these is negative and one of them is positive. So let's start with 1 and negative 33, 3 and negative 11, 11 and -3, and 33 and -1. Taking a look at the sum, we get that this is -32, -8, and this is +8. We know we have 11 and -3. So we know our factor is going to be x plus 11 and x minus 3. It's going to be equal to 0. So we know it's going to be x equals -11 or x equals 3. Here we have 36x squared plus 36x plus 9 equals 0. Looking at this, the first thing I'm going to do is factor out a 9. Because the smaller the numbers are, the easier they are to work with. In this case, let's take out a 9. This gives us 4x squared plus 4x plus 1 equals 0. And now, looking at this inner trinomial, does it look like the difference of the squares or perfect square trinomial? Yes, it's actually a perfect square trinomial. So, a perfect square trinomial will look something like a plus b squared equals a squared plus 2ab plus b squared. And as you can see, this is 2x squared times 2 times 2x times 1 plus 1. Which means this is going to be 9 times 2x plus 1 squared equals 0. And I normally check whether it's a perfect square trinomial if this term is a perfect square and this one is, and I check whether 2 times ab will be this middle term. In this case, it is. So solving for this, we know that 2x plus 1 equals 0 is the solution, and x equals -1/2. In this case, this is a double root, and both roots are -1/2. Here we have 2x squared minus 10x minus 9 equals 0. Let's start with checking whether it's a special product. It's not the difference of squares, and it's not a perfect square trinomial, which means we can start with the AC method. This is ax squared plus bx plus c equals 0. So we know b times q should be equal to ac, which is 2, times -9, which is -18. And p plus q is going to add up to b, which in this case is -10. Let's look for the potential p and q. We wanted to multiply -18. We can do 1, -18, 2, -9, 3, -6, 6, -3, 9, -2, 18, -1. And now, let's look for a sum of -10. So we have -17, -7, -3, 3, 7, and 17. As you can see, none of them are equal to -10, so we need the quadratic formula. So, x equals -b plus or minus the square root of b squared minus 4ac over 2a, which is equal to 10 plus or minus square root of -10 squared minus 4 times 2 times -9 over 2 times 2, which is equal to 10 plus or minus 100 plus 4 times 2, which is 8, times 9, which is 72, divided by 4. Gives us 10 plus or minus square root of 172 divided by 4, which simplifying that, we could take out a 2 because we can divide 172 by 4, which gives us 43 by 4. We can get If we divide everything by 2 here, we can get 5 plus or minus the square root of 43 divided by 2. So we know that one of the x's is 5 plus the square root of 43 divided by 2. And the other one is 5 minus the square root of 43 divided by 2. Here we have 49x squared minus 28x plus 4 equals 0. Does this seem like a special product? Let's check. It's definitely not the difference of squares, but could it be a perfect square trinomial? The reason this makes me think this is because 49x squared could be a, and a could be 7x, because 7x squared is 49x squared. And then here we have a 4, so b could be something like 2. Because 2 squared is 4. Because this is a negative, I would want to check whether this is negative 2ab. So negative 2ab will be equal to negative 2 times 7x times 2, which is equal to negative 28x. So we know this is a perfect square trinomial in the form of a minus b squared, where a is 7x and b is 2. This looks like 7x minus 2 squared, and we know this equals 0. So we know that we have a double root, where 7x minus 2 equals 0. So we know that x is 2 divided by 7. We've reached our final challenge question. My challenge for you is to solve for x for this equation, but to solve it in 2 different ways. So pause, try to solve it, and comment your answer down below. Now, let's get started. The first thing I'm going to do is move this negative 27 over so something's equal to 0. So I'm going to write it right here. 12x squared plus 36x plus 27 equals 0. Now, for my first way, I'm going to write it on this left side. So 12x squared plus 36x plus 27 equals 0. The first thing I'm going to do is factor out a 3 to make the number smaller. Gives us 4x squared plus 12x plus 9 equals 0. So the first check is whether this is a special product. It might be, because 4x squared could be 2x squared, and 9 is 3 squared. So let's check to see whether this middle term is equal to 2ab. 2ab equal to 2 times 2x times 3, which is equal to 12x, which means this is a perfect square trinomial, which means this is equal to 3 times 2x plus 3 squared. So we know that 2x plus 3 is equal to 0, 2x is equal to negative 3, and x is equal to negative 3 divided by 2. Now, we've solved it by recognizing this is a special product. But we can solve it a second way with either the AC method or the quadratic formula. So let's start by copying this over. We have 3 times 4x squared plus 12x plus 9 equals 0. In this case, I'm just going to choose to use the quadratic formula. So we know that x equals negative b plus or minus the square root of b squared minus 4c over 2a, which is equal to negative 12 plus or minus the square root of 12 squared minus 4 times 4 times c, which is 9. 2a is going to be 2 times 4. This gives us negative 12 plus or minus square root of 144 minus 4 times 4, which is 16, times 9, which is 144, divided by 8. As you can see, 144 minus 144 is 0. This cancels out and gives us negative 12 divided by 8, which is also known as negative 3 divided by 2. As you can see, there's different ways, but we get the exact same answer. And that's the end of this video. Thank you so much for watching.